Dear students, today we are going to start the next unit, that is hydrocarbon, and the very first SLO of hydrocarbon, that is naming carbon containing compounds. And especially in this, the focus is cycloalkane, because the other you have already discussed in a form of alkane, alkene, and alkyne in grade 10. If you want that video, then I can also upload that, but I guess that you can have a simple recall of the previous concept, and then the new one is cycloalkane, you can understand from here. So before starting the naming of alkane, we can see there are some names which we use for carbon. For example, for first carbon, we use meth. If there are two carbon, we use eth. For three carbon, prop. Similarly, for 4, 5, 6, 7 till 10 carbon, we are going to use bute, pent, hex, hept, oct, non, and dec, right? So if we are having the cyclic structure under consideration, in cyclic structure, there must be at least three carbon atoms should be there to make the simple cyclic structure, or the minimum number of carbon atoms should be three, we can say. So I have crossed meth and eth, they cannot be in cyclic form. The cycle would start from three carbons, so prop can be in form of cycle, and the name of cycle would be very easy. It is cyclopropane. Whatever the name of alkane is, if it is going to be in cyclic form, it would be cyclo butane, cyclopentane, cyclohexane, likewise. So let us see the skeletons over here. In this first skeleton, we have three carbon, 1, 2, and 3. So that's why it is cyclopropane. In second structure, we have four carbons, 1, 2, 3, and 4. That's why it is cyclobutane. If we have a pentagon in which five carbon are there, 1, 2, 3, 4, 5. So it would be like cyclopentane, and so on. Like if we take example from here, there are eight carbon. How come we know there are eight carbon in ring? We would count the number of corners present over here. If I start from this, there is one first corner, second, third, fourth, fifth, sixth, seventh, and eighth. There are eight corners over there. So the shape is octane, and it is the cyclic compound. So we are going to say cyclooctane. So all these compounds would be with the similar naming of alkane, but we would use the word cyclo if the compounds are in cyclic form. Another thing that we have already discussed, that when alkane remove one hydrogen, it convert into alkyl. Okay, if we take the example that we have discussed for methane, that is CH4, if I remove one hydrogen from methane, it would be CH3 radical, and it would call methyl. Instead of methane, what we call methyl. We add word YL at the end. Similarly, in cyclic structure, if this cycle is connected in a form of radical, in a form of branch to anything, so it would be propyl in a form of cyclic structure. Like we can say cyclopropyl or cyclobutyl, cyclopentyl. In this, how many carbon are there? 1, 2, 3, 4, 5, 6. 6 carbons are there. So it is cyclohexyl, because it is connected to something. It is the parent which is attached to something. So it is cyclohexyl. Similarly, if we have 7 carbon and it is attached in a form of cyclic structure to any other structure, it would be cycloheptyl. Okay, students, so we have here two compounds, compound A and B, we must say. And these compounds are cyclic compound. Compound A is having 6-member cycle, 1, 2, 3, 4, 5, and 6. And a substituent attached, that is CH3. What is substituent attached? That means if something is attached to the cyclic compound by the replacement of hydrogen, that is known as substituent. So similarly, the compound B, if we take, in this compound B, we have a 3-member ring, 1, 2, 3, and a substituent attached, which is made up of 1, 2, 3, and 4 carbon. 3-member ring and 4 carbon are there. And here we have 6-member ring and 1 carbon in the substitution. Now, how we would name them? The name for these compound would be according to the rule number 1. Now, what rule number 1 tell us? Use the cyclic structure as parent if it has the greater number of carbon than the alkyl substituent. If you remember that we followed the naming pattern for alkyl groups or the substitution that were attached on linear chain, like we were having this linear chain. So we selected this as a parent chain and this one as a branch. So now what should I select here? This one as a parent or this one as a parent, the cycle as a branch or CH3 as a branch. To avoid that confusion, what we have rule over here that we have to check for the number of carbon. If the number of carbon of the substitution are more, then it would be parent. If the number of carbon of cycle are more, then it would be parent. In case of compound A, there are 6 carbon in the chain and 1 carbon in the substituent. So I must say the CH3 is branch, right? It is branch and this one is the parent chain. And the name would be followed by 1-methyl, because the branch is of one CH3 group, so it would be 1-methyl, and the parent is cyclic, so that's why cyclo. And how many carbon are there? 6, so that's why hexane. Right? It is 1-methyl cyclohexane. But in this case, I cannot write the name uh, with cyclic structure as a parent. Why? Because if we see, there are 4 carbon in alkyl group and 3 carbon in cycle. So if I write like 1-butyl cyclo, how many carbon are there? 3, so propane. It would be wrong naming. Why it is wrong naming? Because the butyl is having more carbon than propane. So that's why we must follow the naming pattern that is in the number of carbon atom order. So we would write it is, now we can see the propyl group is attached on second carbon. So the name of this compound is 2-cyclopropyl 2-cyclopropyl butane. Okay, that name is right because butane having more number of carbon should be the parent and the cyclopropyl having less number of carbon should be the branch. Okay, students. So there is another rule, that is rule number 2 as per our learning. In second rule, we would number the carbon skeleton of the ring. Like if we have 6 member and there are 2 substitution. Previously we discussed there was only one substitution. Like we have a 6-member ring in which we had CH3. So it is only one substitution. So we would always consider this carbon as a carbon 1, right? If we have like benzene skeleton and we have CH3 here, so we would consider this carbon as carbon number 1. Whenever the substitution on this cycle is, we would consider that carbon as carbon number 1. But what if we have 2 substitution? Like in this, we have 2 substitution. What 2 substitution we have over here? Both are same and both are of methyl group. If I highlight it over here, that one is methyl CH3 and that one is also methyl group. So if we have 2 substitution that are similar, so what should we do? In which order we should do numbering? We should do numbering in a way that we may give the lowest number to the branches. Here we have 2 skeletons, skeleton number 1 and skeleton number 2. If I write it as A and B. So in A, the methyl is on first carbon, the second carbon and third carbon. We are having 2 substitution in an order, which is 1,3-dimethyl methyl cyclohexane. Okay, it is 1,3-dimethyl cyclohexane. If I would start numbering from this side, instead of numbering from this side, I would have two substitution on the 1 and 5 position. Carbon number 1, 2, 3, 4 and 5. That must be the wrong selection of numbering. Why? In this we would have 1,5-dimethyl cyclohexane, right? So if we have 1 3 instead of 1 5, so that one is right. But this one would be wrong because the substituents are having the highest priority of carbon instead of the lowest number. So we always select the numbering pattern in which we would have the lowest number. Okay, let us do one more example. Here we have three substitution and three are same, right? So if we start numbering in this order, like from this to this side, so we have carbon number 1, 2, 3 and 4. We have three substitution on carbon number 1, 2 and 4. So it could be 1, 2, 4 trimethyl cyclohexane. But if I start numbering in a wrong pattern, like if I start numbering from this side and follow in this pattern, so it would not be right. Why? Because the two adjacent carbon would have the far number. Like if I'm going to start from this 1, 2, 3 and 4. Now this would have 1, 3 and 4. The highest priority would be there 1, 3 and 4. That is the more number as compared to 1, 2, 4. So if we can arrange the numbers of carbon as 1, 2 and 4, we would not select that pattern that is incorrect, that is 1, 3, 4. So we can say second rule is telling us if we have more than one substitution, so we should have the arrangement of numbering in this order, which would give the least number to the substitution or the branches attached to it. So we would have that type of arrangement over here. Okay, students, we have another part of rule 2, that when we have more than one substitution, and these are different. Like first of all, we discussed that we have carbon chain, carbon ring, sorry. We have carbon ring in which we could have one substitution. Let me make it more clear for you so that you can understand. Previously, we had a single cyclic structure on which we were having the first substitution that we named is 1-methyl cyclohexane. Then we discussed if there are more than one substitution and these substitutions are of same kind, like we discussed if we have 2-methyl attached, CH3 here and CH3 here. So we would number in a way that these two branches should have the lowest priority, 1, 2, 3, 4, 5, 6, right? We would move this side because that is going to give us the least priority to the branch. So this that is 1,3-dimethyl cyclohexane. Now the case is different. Here we are having more than one type of substitution. If we look in this structure, what we have, in this structure we have a benzene ring. Sorry. Uh, in this structure, we are having one benzene ring. In that benzene ring, we are having two substitutions. The substitutions are present in a form of 1 and 2. That means it is C2H5 group, ethyl group. And this substitution is having only one carbon, so we can write it CH3 group. Now, from which end I should start numbering? Should I start with this type, like the lowest branch, 1, 2, 3, 4, 5, 6, or I should start from the highest branch, that is 1, 2, 3, 4, 5, 6, like in this order. So when we have two type of substituents arranged, so we should always start numbering in alphabetical order. Now for these two substitution, the first substitution I must consider this, which is ethyl group, because E come first, then come M in alphabetical order. So I would write the numbering from ethyl. I would start from ethyl. It is the first one, 1, and that one is the second one, 2. It is 1, 2, 3, 4, 5, and 6. So the name must be 1 ethyl. Always write hyphen when you write number and alphabet. In between you are using hyphen. 1 ethyl, then 2 methyl cyclo, because the parent is cyclic in nature, cyclohexane, 6-member ring. Okay, so it is 1 methyl, 1 ethyl, 2 methyl cyclohexane. Similarly, there is the incorrect representation. If I start from the lowest branch, I would write 1, 2, 3, 4, 5, 6. So name could be 2 ethyl, 1 methyl. So it would be the wrong pattern. The right pattern is what? We would move according to alphabetical order, and the E come first, then come N. So we are going to write 1 ethyl, 2 methyl cyclohexane. Let us take one more example. If I use a pentane ring in which 5 members are there in a cycle, so that one is cyclopentane, right? In cyclopentane, I have that branch attached and that branch attached. Okay, so if I can, uh, if I want to know how many carbons are there, so in this 1, 2, and 3 carbon are there, and in this only 1 carbon is there. So as we know that if the cyclic structure is having more carbon, so it would be considered as a parent, and these two would be considered as a branch. So which branch would come first? If we look for this, this one is methyl and this one is propyl group. So methyl M come first, then P. So we would start from this side. This one is 1 and 2. I must write it is 1 methyl, 2 propyl, cyclo. What could be the name of 5-member ring? Pentane. Right? So it is 1 methyl, 2 propyl, cyclopentane. Okay, let us move towards rule number 3. The rule number 3 is going to tell us the substitution if they are like halogen members. So if fluorine is present, we were used to write fluoro, chloro, chromo. In normal nomenclature of open chain compound or aliphatic compound, we would follow the same pattern over here. So here we have one structure in which 4-member cyclic structure is there, that is butane, and 2 substitution are there, CH3 and Cl. So methyl, as we know, M come after C in alphabetical order. So the name of this compound is 1-chloro 2-methyl cyclobutane. If I take this example, like if I have a 6-member ring, right, in which I have Cl and then I have iodine. Now, what could be the name? First of all, we should start numbering in that order which is going to give lowest priority. So I should start numbering in this way. And now which one is like chloro and iodo? Which one is with the alphabetical order which come first? So C is like come first, then I. So I would number this as 1 and this one as 2. And it is hexagon, so we can clearly understand it is a 6-member ring. So the name of compound would be 1-chloro, because we know chlorine would be chloro, then 2-iodo cyclohexane, right? The name of this compound would be 1-chloro 2-iodo cyclohexane. Okay, students, there are some practice questions that you must practice after understanding the rules so that you can have idea that either you are able to name the compounds or not. So let us start from compound A. This one is A, B, C, and D respectively. Okay. So first of all, I want you to try the naming of A. What could be the naming of A? As we can see, there is a three-member ring, carbon number 1, 2, and 3. Okay, and there are three substituents attached. The first substituent, second, and third. Right? All substituents are made up of one carbon. So there are three methyl groups. Now, from which end I should start numbering? As the substituents are same, so I would start from the priority order, which is having more substitution. So I would write this one as 1, this one as 2, and this one as 3. We have three member ring in which on first we have 2 methyl and on second we have 1 methyl. The third one is free. So the name of this compound must be 1, 1, 2 trimethyl. The ring is cyclic in nature, so we must say cyclopropane, right? The name of first compound is 112 trimethyl cyclopropane. Let us explore the second one. In second, there is a ring and the attachments are both on first carbon. So I would write 1 here, 2 and 3. Now, if we see, there are two branches which are dissimilar in nature. The first branch, I must say, is two member and the second one is first member. So this one is ethyl and this one is methyl, right? One ethyl substitution and one methyl, both are on position number 1. So what could be the name of this compound? I would start with alphabetical order. I would write 1 ethyl, 1 methyl, then cyclopropane. Understand? One ethyl, 1 methyl cyclopropane. Ethyl, E come first, then come N. That's why we are going to write 1 ethyl first and then 1 methyl. Okay. In second rule, we studied that if the substituents and the cyclic are having the same number of carbon, that condition is present over here. And we have already discussed that if the ring is of 3 member and the substitution is of 3 members, so we would follow the naming pattern. This one is a parent chain and this one will be considered as branch. So the name of this compound would be 1-propyl, or we can say propyl cyclopropane. What would be the name? The name would be propyl cyclopropane, right? Now the last one is again the three-member ring with different substitution on different position. The first substitution we must say is methyl group, and the second substitution which is attached is it is ethyl group. It is made up of 2 carbon atoms, right? These 2 carbon atoms are connected here. So the cyclic ring would be the parent and these two would be considered as branch, but which branch is 1 and which one is 2? Now you must be very clear about this thing. Ethyl, E come first, then come N, so that one is 1, 2 and 3, right? The name of this cycle would be 1 ethyl, 2 methyl cyclopropane. It is 1 ethyl, 2 methyl cyclopropane. Okay, students, so here I have added some more examples for practice. So we are just going to name them. This one is compound A, B, C, D, E, and F respectively, right? So if we name compound A first, So we can see there is only one substitution. So this position would be 1. And we are just going to count the name of number of carbons. So these are 1, 2, 3, 4, 5, and 6. Or we can exactly identify by the hexagon that there are 6 carbon. So the name of this compound would be 1-bromo cyclohexane. On position number 1, if it is attached, so it may be written or not, it doesn't matter. We can also say it bromo cyclohexane, right? The first name is for bromo cyclohexane. Okay. So now here we can see there are two substitutions. The first is in a form of we can say alkyl form, and the second one is in a form of chlorine, right? So if we have that type of attachment in which the ring is in more number of carbon than the attachment, so we would consider this thing as a branch and this one as a parent chain. Because it is a pentagon, so we can identify there are 5 carbons, and in substitution there are 2 carbons only, 1 and 2. So that's why we are going to have this one as a parent and this one as a branch. Now if we consider this carbon as a attachment, so we would not start numbering from here, we would start numbering from here. That one is carbon number 1, that one is carbon number 2. Why? Because the carbon which is near to the branch would be considered as carbon number 1. So in carbon number 1, we have two things attached, chloro as well as that parent chain. So the name of parent chain, as we would write at the end, and the name of branch we would write at the start. So what could be the name of this? The name of this compound is 1-chloro, because the chlorine is on 1. So 1-chloroethyl, sorry, my writing is so bad. 1-chloroethyl, and what come next? The parent name, that is cyclopentane, right? The compound is 1-chloroethyl cyclopentane. Okay, let us move on the next. It is very easy. Only one substitution is present, that is methyl substitution. And the 3-member ring is over there. So the name of compound would be methyl cyclopropane, right? Methyl cyclopropane. Now, let us come towards the T structure, in which how many carbon are there? 1, 2, 3, 4, 5, 6, 7, and 8. There are 8 carbon. Now, which one is in lowest alphabetical order pattern? So, as we know that I come after B, so this one would be first. Now, if we can see, the pattern is same if we move from this side or either we move from this side in numbering. So both pattern would have the same position because these are just opposite. So I'm going to start numbering in this order: 1, 2, 3, 4, 5. Right? If I would start from this, so it would be 1, 2, 3, 4, 5. Both are same. So I'm going to write the name, that is 1-bromo. Right? Why I considered Br or the bromo first? Because B come first, then come I. So it is 1-bromo. On which position iodine is present? Position number 5, and we call iodine as iodo. 1-bromo, 5-iodo, and that one is 8-member ring, so it is cyclooctane. Right? Now, in this we have one methyl substitution and one iodo. So if we see I come first, then come M. So I would write this one as number 1, 2, 3, and 4. What could be the name? The name could be 1-iodo, 3-methyl butane. Understand? 1-iodo, 3-methyl butane. Now the last structure we are going to discuss, just I'm going to count the number of carbons: 1, 2, 3, 4, 5, 6, 7. That is cycloheptane, right? That is 7-member ring cycloheptane. Now on which position I should start numbering first? As we know that this one is two member rings, two member attachment, so that's why it is ethyl. It is only one member, so that's why it is methyl. So I would prefer this one to be one, right? And if I count from this side, so it would come 1, 2, 3, 4 on fourth position. And if I count from this side, so it would come from 1, 2, 3, 4, 5. So this position of numbering would not be right. This one is right. And the name of compound is 1-ethyl 4-methyl cycloheptane, right? Because the E come first, so I'm going to write 1-ethyl first, 1-ethyl, then on position number 4 we have methyl, so 1-ethyl 4-methyl, and the parent chain is of 7 members, so that's why cycloheptane. Hope you enjoyed that video, and if you have any question you can write, and I will try my best to give you resources related to this in a form of practice sheet in description box. Thank you.